Hey, so welcome back to the joint and table where I fix stuff. Today we're looking at the Monroe, which we fixed the carriage on previously. We're going to see if we can get the rest of this working today. The person I got this from said that when they plugged it in and turned it on, it made a horrible screeching sound and then the motor stalled. So there's probably a bunch of stuck parts down here in the bottom as well. But I wanted to take care of the carriage first to make sure I could get that all sorted out before I started working on the bottom. And then since we finished the carriage previously, we can now start working on the main body of the machine. So I just put the carriage back on temporarily. I didn't screw it back in, but I should be able to just pop this off real quick. Put this out of the way since we don't need it for right now. So, we can pull this little latch here, and then this knob will come out. That's where the crank goes on if you don't want to use the motor. Take some of the screws out. There's 4 screws in the cover here. There's one on each corner, so there's going to be one here. There's one down there in the back, and the same thing on the other side. So I'll get those out. So with all those screws out, you got to take this one screw out of this thing, this little knobby thing here. And this goes off. Now, I think on this one you also have to take the keys off because this is one solid piece, and the lip here wraps around under these keys. So let me take those off too. Okay, so plus and minus keys are off. We should be ready to take this off now. Yep. So we can get our first look at the inside here. It's pretty dirty there. That's the switch for the motor. So the motor only runs when it's actually doing something. It's not like the Marching EA what runs all the time and then just has a clutch to engage it. This one actually turns off the motor when it's not operating. So let me find my crank we can put on the side here, or my broken crank we can put on the side there, and see how stiff this is. So just pop the crank in here where the knob came out of. Actually not that stiff at all, really. Huh, that's interesting. Maybe just the motor bearings are stiff then. Let's see, if I push, this was a plus, right? Yeah, so it should stop. When you push a key, it has a bumper on the other side so that it stops after exactly one cycle because the motor has a lot more momentum. Now if I turn this by hand, I can keep turning it for forever because you can turn it until you're done. So this, I think, is the stopping point here. So keyboard clears, except for this one because the item counts down. Now it clears. It's actually very, very free. Really spinning. Can you even see what's going on here? Give you a better view. Gee, this is pretty free. So I think I'm going to take the motor off and see what the motor feels like, since the rest of the machine is actually surprisingly free. All the keys seem, well, I didn't try all of them, but most of the keys that I tried all feel pretty good. So the motor has its own special little bracket on the side there. So there's its own special bracket. You can see this is part of it, and then it kind of loops down and around and underneath the motor. So I think there's a couple of screws on the bottom of that you can take out and then just slide the motor off. So let me look into that. When the motor comes out, there's these 2 bolts in the bottom of that bracket that hold it on. So that comes off. So let's see if this is frozen or not. No, it's not. Oh, that's interesting. I wonder what that person was talking about then. So everything that I see seems free, unless there's something wrong with the motor internally, like the coils are shorted or something and it's not driving it properly. But this seems very free. Just put some oil into it anyway. But yeah, I might try powering this up out of the machine. So you can probably just hook right on here. I'm going to have to redo this wiring anyway, because I can't see that. Because somebody has just took a line cord here and kind of just split the wires off, but there's nothing actually attaching this to anything, so that's not going to fly. So let me see if I can just hook these wires right up to these terminals here temporarily and see what happens when we apply power to this motor. So I ended up just hooking a jumper across the two connectors on this plug, because these are the connectors that go to that switch, so when the machine wants to drive the motor, it just connects those together via that switch there. So this should bypass that and just apply power to the motor. And put a bunch of oil in here before we do anything else. Ooh, that's a bit too much. That's okay. These are well oiled, but it definitely seems free, so not quite sure what story is behind what I heard. So just plug this in and it should do nothing because the switch is off. Yeah, that one's fine. As you can see it in the camera, but the inductive load makes the lights dim a little bit when I turn it on. The vibration is just my table. This is a cheap table, so if I hold it down, it doesn't vibrate the table. Yeah, anyway, okay, let's put that back on and just temporarily try it out, since this seems so free. I really don't understand what I was told. So I'm just going to put this back on, and then if everything looks fine, I will have to figure out some sort of solution to this wiring mess. Okay, so I went ahead and put some oil on the planetary gear set back there, and also the bushings on the shaft in the back. And I'll plug this in and turn it on and see what happens. Actually, I should probably plug it in first. Forgot to plug the motor. Okay, this time the motor's plugged back in. That didn't sound good. Interesting. Well, it's definitely not seized, at least. Let me take a look at what might have happened there. So I think the problem was that because I had been turning it over, it was kind of like engaged in manual mode. So the stop that's normally active when it gets to the end of a cycle in automatic mode was not active, and that's why I kept going. I'm not sure if it's supposed to go that fast, and I'm also not sure why doing it in manual mode engages the switch. It's kind of weird. Yes, something did fly out, and that was this little thing right here, which is the bottom of a rivet that was right here. That just keeps this shaft here, side to side wise, in shape up at the top, and I think that broke because of the carriage being jarred and shipping. This is the carriage shifter, so this spins around to move the carriage one direction or the other, and it's bent because of the carriage being jarred. I think that's what broke that rivet there. I'm going to see if I can steal this piece out of the pouch machine so I don't have to try and unbend this one, but it won't even go in a full circle because it's bent. So I got it back into automatic mode by just pushing this key down and then turning it manually, and then it got to the end and it stopped. So it should be safe now to plug this in. Yes. So it's plugged in now, the motor's on and it's not running. Should be able to push a button. That doesn't seem quite right. So for some reason it's not stopping at the end of the cycle. That's interesting. So it stops there. See what happens if I plug it in now. Nothing. Okay. So what happens if I push this button and then plug it in? Still wants to take off for some reason. I'm not sure if it's supposed to go that fast. So something is up with it not stopping at the end of the cycle. So I'll push the button. Yeah, see it stops or then it keeps going. So that would be over in this mechanism on that side, I believe. So let me see if I can take a look at that and see what the issue might be. So the problem with this machine is it's actually too free. So you can see how the handle is pointing straight up. That's the home position. And watch, if I push the plus button, it'll go through a cycle, it'll come to its stop, it'll bounce off the stop, and sometimes it'll bounce back so far that it goes right past the stop position and back into the cycle. It's especially true on subtraction. So watch here. See that? So it bounced way back into the cycle and then returned home. Sometimes it takes longer than that if it bounces way back into the cycle. Like that, see? And it's slowly coming back up towards home. Of course, the motor is disengaged from it, so it's only like its natural tendency to come to home that's driving it now. So I think that part of the problem is there should be more restriction on all the machine in general, so that it doesn't bounce back so far when it bounces off the stop. Now watch the traction, that'll bounce way back into the cycle, so far back it won't even come home. So that bounces way down there, and then it's just, at that point you have to stop it and manually bring it back up to home, or it just bounced so hard off its stop. So I think there's definitely something up with that. Certainly not a problem I expected to find. Didn't know it was possible for a machine to be too loose. Whereas if you hold it down, it'll do multiple cycles. So the issue that I think might have been what we were having earlier, where it seemed to be like it was over speeding. I think that might have been the planetary gear set might have been somewhat stuck, and instead of providing a gear reduction, it was just locked up and then driving the whole machine at the speed of the motor instead of providing a reduction of the gear set. I think that might have been the issue there, because it definitely seems a lot better now. It definitely seems like a more reasonable speed than we were seeing earlier. I definitely got to figure out what's supposed to be restricting it and why it's not being restricted, because it's just completely unacceptable that you have to manually turn it off and reset after every subtraction because it bounces back so far. So I might look at the post machine and see what kind of restrictors there are on the post machine. I know that some of these machines had like just metal, basically it almost looked like kind of like a cotter pin with the head being open, and then that went around the shaft and kind of just acted like a spring brake. I did see that there were some on one of the shafts, but maybe I'll see if I can get at those and maybe just bend them a little bit tighter to provide more restriction. We'll have to see. But definitely it seems like it's too loose. If I unplug it here and go by hand, I just spin it. But that's definitely not enough restriction. And that's why it bounces back so far every time. It ends the cycle because there's not enough restriction on it to keep it from flying all the way back like that. There is a spring-loaded detent type thing, so if you turn it a little bit, see, it'll come back. But once you get out of that range, then that doesn't help anymore. So like if I go down here, then I'm out of that range, so it won't return easily. Same thing over here, but just like on either side, that spring pulls it back. So yeah, definitely I think that there's an issue with the restriction. The keys work though. You see it drove those wheels there. Can you see that? I think you can see that. Even that doesn't provide much restriction either. So I'm going to take a look at the post machine and see if I can figure out what breaks on that. Although I may take a look at the brakes that I did find on here and see if I can maybe make them a little bit tighter. So the keyboard was actually surprisingly easy to take out on here. There's just 4 screws, one here, or 5 screws rather. There's one here, and here, and then just one in the top right there. And the whole keyboard just lifts right out. So that's nice. The brakes are these things. They're just friction brakes. And they just snap around right here on this little thing that just goes back and forth. This whole shaft rotates, so you got a certain amount of time before it hits here and then drags this with it. And both of them were pretty loose. There's one here and there's one right there. This one I've tightened up somewhat. Not sure if it'll be enough, but see, this is somewhat stiffer on there now. Than this one, which is just completely free because it breaks off. So I'm going to see if I can tighten these up, and hopefully that will fix our issue with it overshooting. So then you figured out what the problem with this machine is. It turns out the machine is actually smarter than me because it can detect whether you've got the crank or the knob in, and it adjusts the dampening accordingly. So look over here on this side where the control mechanism is. So when I put the crank in, you'll see that this piece is lifted up out of the way and everything turns freely. If I put the knob in, oh, it latched on here. If I put the knob in, you'll see that this drops down and acts as a bumper, so the machine can't rotate in either direction. Let me just show that again. I'll take the knob out, pop the crank in, and you'll see that that lifts that up out of the way so that it doesn't dampen it anymore. If I swap them back out, see, now it's the dampener is reactivated and the machine won't rotate out of its home position very easily. So that's what is actually supposed to stop it from bouncing back too far at the end of the cycle. Because now, if I plug this in and run it for a few cycles, you'll see that it'll stop at the home position every time. So you stop at home. So that seems to have fixed that problem. Just gotta understand how the machine works first. And the way that that works is, if you notice on the knob, it's got a flat end there. You can focus. Oh, almost had it. So close. That's got a flat end, and the crank has a much pointier end. And those ends engage on this thing right here. You can see that. Engage on this little tip right here, which pushes on this shaft, which runs all the way over here and activates a little ramp thing that pops out the bottom here that lifts this up. So you'll watch if I put the crank in. Watch right here, you see the little ramp pop out that'll lift that up. See it right there? That little thing right there. If I take it out, see it retracts and drops back down again. So that seems to have fixed the issue of it bouncing back every time after the cycle ends. Just gotta use the right knob. So that's something on a chase for a while, but got it figured out in the end. I don't think the brakes are as important on the electric machine. I think they're just there to, make sure you don't crank it too fast when you're doing it in manual mode, I guess. I don't really know. The post machine, the brakes on that didn't seem to have, that much braking force either. They were a little bit tighter than these, but still not that effective. So I'm not going to worry about the brakes. I'm always going to run this in electric mode anyway, so I don't think that's going to be an issue. So I think the next thing that I want to do is clean up the wiring on the motor. I'm not sure how this was wired originally, because there doesn't really seem to be any sort of thing on the motor to clamp this wire to. But you can see that someone has, redone some of it. And there is some marks on here. I'm not sure if you can see that, but it looks like there was a clamp on here at some point, but I'm not sure what it was clamped to, unless the person that had this before just had it clamped to their table or something. So I'm going to see if I can figure out something to mount this more securely, or maybe see if I can, bring it up inside the switch box here and maybe, wrap it around that or something, or tie it or knot it or something. I'm going to probably replace this wire too, because you can see it's been wearing through on the carriage. It doesn't look like it's all the way through, but it might not hurt to change it anyway, because I want to get in here anyway and see if I can somehow fix this wire inside this box, but we'll see. I tried to find pictures of this particular version, because this is an older version of the motor than the other Monroe Model K that I have. This one has the two terminals on it, whereas the other one that I have, this wire goes right into the motor, and then the wiring goes internally in the motor over to the switch and then out to the machine. But this one is different, so I couldn't find any pictures of how this was done originally, so we're just going to see if we can make something up. But after that, I think this machine will hopefully be ready to put back together and test. So we've redone the wiring here. It's not perfect, but it's better than it was just flopping out in the breeze. So the main wire now goes into the bottom of this box here, and then the switch occupies the space between here and here on the inside. So the switch basically clamps this wire down against the outside of this container. Again, not perfect, but there's really nowhere else to. You can't put a one of those wire clamps in here because it's just a little tiny hole. So for now, that's the best I could come up with. Maybe in the future, if I think of something better, I can do that. But at least for now, when you pull on this, it's not going to rip right off the motor or anything. So I think it'll be okay. I did do some rerouting. If I can show you without my tripod killing me. These two terminals are where the power goes into the motor, and as you can see, there is exposed metal on there. So this is, definitely UL approved right there. And as soon as you push the button, you could grab this, and that's 110 volts right there, 120 volts. I think the way they had it, they had power going to here first, and then to the switch, and then to the switch inside the calculator. I think I did it backwards, so power comes into here first, and then through this switch, and then over to the switch in the motor, and then back to here, and then this is the, and then from here back to the neutral into the line. So this will only be live now when the machine is actually running through a cycle. Like I said, I think the way they had it, as soon as you plugged it in, this would be live. So this was live all the time, assuming the calculator was plugged in the way they had it before. So it should be, somewhat safer now. I also rerouted one of the wires. So the way that it was before, both of the wires from this plug here went into this box and then out to wherever they were going. I did it a little bit differently. I have one of these wires coming from here right over around the bottom of this box right into the plug, just to save me some space in the plug, because I think my wires are a little bit thicker than theirs, and it was getting really tight to fit them through the holes in the box, so that saved me some space there. I think it'll be okay. On the old wires, put my tripod back down. The old wires, I think it's kind of interesting how, at the part where it looks like it might be bending, they put it and wrapped an extra string around it as kind of like a strain relief. You see, here's the normal wire, and then here's the extra cord wrapped around for strain relief. And they did the same thing here too. So that was kind of cool. I think it is time now to put the keyboard back on. So when I'm putting the keyboard back on one of these machines, very important part is this little swingy thing right here. The first time I took one of these apart, it took me forever to figure out how this was supposed to operate. What this is this is the keyboard clearer thing. So whenever this gets pushed on, that's what clears the keyboard. That is activated off of a little tong. I'm not sure if I can see it from here, but it's activated off of a little lever. Let me think. Actually, that would be right here. So it must be this lever right here. I think that activates that. Yeah, that would make sense. So when I push the clear key, we can't really see that. So this right here is what's going to activate it. So when I push the clear key, you can see that moving. It's going to come out and hit on there. So if I'm going to have to hold this back when I put the keyboard back in to make sure that it gets behind there. So this should just slide back in, hopefully. Usually things do not go as easy as they should. Hanging up on this side. So you have to get it exactly straight, because it's machined, the keyboard frame is machined to meet the machine frame. Okay, so we've got it started, and these two keys are poking through. So the clear key, and then these two are the repeat and non-repeat toggle. And it's got to fit on these things here. So it's going down. Now it's stuck on the release. There we go. Okay, so it's very close, I think. I think that might be it. Actually, I have to make sure that goes in right. There we go. Now I think it's all the way in. Yes, it looks pretty flat. So, if that's correct, my screws should slide in. And they do. So I'll screw this back in. We've got one screw in each corner, and then the one little screw that goes in the top there. And then we can, make sure the machine still works and everything, which it should. Just to make sure we've got everything lined up properly in the keyboard. And then we should be able to put the cover back on and put the carriage back on. Okay, as soon as I got this all back together now, I did change the carriage shifting shaft. This is the old one. You can see how it's bent right there. You can see that or not. It's definitely bent right here. It bends, slightly up. And that's why that one pin broke off the keyboard here, because those two pins go on either side of this shaft here like this. So when it bent, this one broke off. So I'll just change the one over from the post machine to here. And now the shift the carriage pretty easy. I also noticed that these little teeth that stick out of the bottom of the carriage, some of those were bent out, so I just bent them back in. They were rubbing on the top of the key plate there. Should be ready to give this a test now, I think. And turn it on. And we'll do our favorite edition here. Here we go, 3330, that is correct. Clear the counter and clear the main register. So let's try multiplication. We'll put this in repeat mode. And then we'll do 625 times 625, so we'll do 625. And now we want, we want to have read 625 in the counter. So we'll hold this down until the counter says 5 in this position. By 1, and then we want 2, and then we want 6. 30625, that's correct. So we can try division. We'll shift all the way out, and we'll do and then we should be able to hold down subtraction until the machine stops, and then we'll add one back and shift over. So this machine should automatically stop when it gets in underflow. And it does. Something didn't seem right there. Let's try that again. It didn't seem quite right, did it? I was thinking wants to subtract. There it goes. Not quite sure what that was about. Maybe I just didn't push the button hard enough. Okay, and there we go, 3.14159290. That is correct. So I think it is official that this machine is fixed. Everything seems to work. So I guess that's about it for this video. And one thing I did want to mention is a lot of the other calculators, starting in the 30s, seem to take a lot of their design, like external design cues from Monroe. So like Monroe has the slightly sloping keyboard up to a double level carriage on the top that slides back and forth. In the 20s, they were pretty much the only ones that had this design. Monas still used their, like big low rectangular box with the keyboard on it, and then just the flat carriage. And Marchant had their special design and had just the accumulator part split up, and the counter part was stationary. You can check out my videos on the Marchant EA if you want to see that design. So a lot of different designs in the 20s, but in the 30s, pretty much all the calculators look something similar to this, with the slightly sloping keyboard up to a double level carriage on the top of the machine. So anyway, I think I mentioned this is from 1922. This is Monroe's first electric calculator. The logo isn't too bad on it. As you can see, it's kind of faded there, but on the back, logo actually looks pretty nice on the back. It's still nice and sharp. It's a little bit faded on that side, but still, pretty good for being, almost 100 years old. But I think that's about it for this video. Really, the only problems with this machine were the shipping damage, I guess. I thought there was a problem with it, not stopping at the end of a cycle, but it turned out that was just it could detect whether you had the brass knob or the hand crank in, and when you put the brass knob in, then that works fine. So, if the carriage had not been damaged in shipping, this machine might have just needed a little bit of cleaning and probably would have been okay. But anyway, that's going to be it for this video. I hope you enjoyed this look at getting the calculator back working again, and thank you for watching.